Number 31, when finding the zeros of a polynomial, you find the zeros of a polynomial, state the multiplicities of each. So you hope and pray to the good Lord above that your functions are given to you in factored form. You hope that they're given to you like this, because if they are, this becomes so much easier. This is in factored form, and they're linear factors. Okay, so you'll see here that, and when you're looking for the zeros, what you do is you say, well, what value can I plug in for x that would give me 0 as an output? Well, if it's in factored form, you remember the zero product property that says 0 times anything is 0? Well, you ask yourself, what would give me 0 inside this one factor? Well, x plus 4 equals, what would give you 0 there? Negative 4 would, that's right. Negative 4 plus 4 is 0. 0 times anything is automatically 0. So one of the zeros here is negative 4. Now, how many times would you get that answer? Well, it's going to be the same thing here, right? Negative 4 plus 4 is 0. What will your answer be right here? Negative 4 plus 4 equals 0, negative 4. And what would be your 0 from this factor? 1 minus 1 would give me 0, so 1. So my zeros are negative 4, negative 4, negative 4, and 1. But you see how this is repeated 3 times? You don't have to do that. All you say is negative 4 is a 0. With a multiplicity of 3. It's repeated 3 times, so you say it has a multiplicity of 3. 1 is a 0. It has a multiplicity of 1, so it's kind of redundant to say it has a multiplicity of 1. But if they ask, you'd say 1 is a 0 with multiplicity of 1. All right. So is the part B the same way? Yeah, it is. So now notice on part A, I didn't worry about the negative 2 because there's no x out here. There's nothing to plug in out here, and I'm going to multiply. So remember, 0 times anything is automatically 0. So if there's just a plain number out here in the front, it doesn't matter about a 0. Okay. Now on part B, there is a value out here by itself, but there's an x. It's an x, and it's x to the 5th. So if you ask yourself, well, what value would I have to plug into x right here to get 0? 0 would, right? 0 would. And now notice it's to the 5th. So the other way of writing this would be this whole function would be g of x equals x times x times x times x times x. Right? 5 of them, because it's to the 5th power. So that means that since you have 5 of them, that means 0 is a 0 of this polynomial 5 times. So 0 is a 0 with multiplicity of 5. All right, what would give me a 0 here out of this factor? 2. 2 minus 2 is 0. So 2 is a 0. But you see how this is to the power of 2? They're basically, this is like saying times x minus 2 times x minus 2. Right? It occurs twice. It's x minus 2 times itself twice. So it has a multiplicity of 2. And x plus 6 is just out there by itself. So what would be the value that would give you 0 here? Negative 6 plus 6. So negative 6 is a 0. And I guess you could say it has a multiplicity of 1. Kind of redundant, but hey, that's what it's asking for. So if you haven't noticed, those powers, if you have this guy right here, it has a power on it, that's your multiplicity, 2. This guy has a power on it, that's your multiplicity of 5. This one didn't have that, but it could have been written x plus 4 to the 3rd, and you wouldn't have to seen that 3 times. But it's a good little way of introducing you to a multiplicity of 3.